Hi, so some of the last people are still coming in. Welcome. Does anyone know who those people are? Anyone? Alan Turing. Yes, that's Alan Turing. The bow guy. Jonathan Neumann. Yes, that's right. So Guido van Rossum, Grace Hopper, Kurt Gödel. Kurt Gödel and Alan Turing really started the field of computer science about 100 years it would be. And then, they started it. Von Neumann really invented basically everything that we're going to do in the course, except for Python, which was invented by the guy in the middle. It's kind of an important figure, 50s, 60s. So kind of before Guido van Rossum invented Python, which we're going to talk about later, she was really the person who drove the idea of not just working with the hardware, but figuring out some kind of how to program in a way that's kind of humanly understandable. So that's kind of what we're going to do this semester, not so much in 190, a little bit. That's the Anxi crest. I don't know if you've seen it. So it was designed by Professor Deleterio, who used to do linear algebra, is retired. So it's unofficial. I checked the copyright. It's fine. We have it all over the place, but it's not actually the official crest. Anyway, it's 4:10. So enough chit chat. Let's start the lecture. So hi. So by the way, the entire thing. So on Quarkus, the course website was linked. If you go to the calendar section on the course website, which is what's there, what you'll see is the slides. So those are the welcome to ESC180 slides, which you could access before the lecture. There's going to be notes posted as well. So those would be the slides, and that is still me. Mike Joy. So I'm assistant professor teaching stream in Anxi. I'm also appointed to mechanical industrial engineering. I don't do a whole bunch of work there. Outside of that, I sometimes do data consultancy, stuff like that. I sometimes consult with famous clients. So I did CDC. If you use homestars.com, so I don't know, like if you are not in charge of the home, like not a homeowner, maybe you don't, but like, like that's what you use in Toronto in order to find contractors and stuff. So I was at some point in charge of the algorithm that would filter out fake ratings, which contractors would give themselves. I think it still works well. I don't know if they're still using my stuff. I've done all this other stuff as well. Specifically with ESC180, I've been with this course since I first started graduate school in 2007. So quite a while ago, I was just like randomly assigned to this course to be a TA. I had no idea what it was. It was just like a random thing. And I really fell in love with the course. So I, stayed with it as a TA. I then taught it a couple times. I, like when after grad school, I stopped for a while, then I came back. I stopped for a while, I came back, and I'm still here all these years later. So in terms of research, I do machine learning, computer vision, applied statistics, stuff like that. So I also do a lot of pedagogical work outside of teaching. So specifically, designing assignments for kind of introductory computer science. So a lot of the assignments that you'll see in this course are actually, published and peer reviewed and used not just by me, but by other people as well, which I'm very proud of. I've done some industry work in the past as well. If you want kind of more about my work, so you can read, U of T News. I'm actually on the front page of U of T News right now. So like that one is there with the nice jacket. Unfortunately, the only nice jacket I own, but you only need the one. You can read kind of popular coverage there. I have like a link there if you want to read a little bit more kind of popular descriptions of what they do at the link up there. So enough about me. So I sent out a survey a while ago, and this is like that. So more people responded. If you haven't responded, please do. I want to hear from all 300 of you. So this is kind of the programming experience, and this is like the usual thing. So approximately half the people have not written, more than approximately 50 lines of code, which means that this course is, for you. If you've written more than that, so if you've written kind of over 100 lines of code, certainly the first several weeks are mostly not going to be for you. As we progress through the semester, the hope is that the people who came in without experience are going to kind of get to the level of the people who have been bored for the first couple of weeks, and then we'll all proceed together as one big happy cohort. With that said, appreciate that I wrote 501 and not 500, given that you know how to program, because the other one was 500. So you might not get all that much out of this course, to be honest. We'll try to keep you entertained as much as possible, but we do what we can. So here's an interesting one. So what majors are people considering? So Aero apparently wins, and that's not unusual. So you should all go to machine intelligence for the record, right? And you will. So historically, at least, there is a lot of people who come in at least considering Aero, and then somehow they end up in MI and Robo, which kind of taken together are way over 50%. So kind of, I should say MI, Robo, and kind of the computational aspects of other majors comprise like way over half of the ANSI cohort currently. Things change, of course. They might change in 2 years when you choose your major, but that's what things are right now. So I think this course is especially important. Even if you go to Aero and you just do fluid dynamics simulations, you still need programming. That was a bit of fun. So when did people respond to the survey? So I'm happy to say that only 3 people responded between 4 p.m. and 5 p.m. yesterday, and 0 people responded between 5 and 6. That is kind of an amazing feat of concentration. Keep it up. A favorite joke. Okay, so I've read all of them. I promise you. I'll read all the ones you submit later. If I didn't select yours, I'm sorry. I selected one like the what happens to a bad aviation joke at Neverlands. Yeah. I hope the Aero people are happy. Why do programmers prefer dark mode? I hope you appreciate the dark mode of that one line. Okay. Okay, so enough of that. 7 minutes in. The class. So everything is on the course website. I do not like quirkers. Sorry, quirkers. Not sorry. apart from that, there is a Piazza forum, which you don't need to take pictures of because I enrolled you in it 2 hours ago. You should have gotten an email to your U of T email address. If you have not, email me. We'll see what's going on. So the Piazza course forum is mandatory. Like the announcement section is mandatory reading. When I post an announcement, it also goes to your U of T email. So like read your email, or read the Piazza. So don't tell me that you didn't know about it. So here's the course description. So this is kind of like a vague course description, which of course, like you need to have taken the course in order to fully understand it. But basically, we're going to be doing programming. We're going to be doing programming in Python. We're going to be talking a little bit about good practices in software development. So how to not just write any program, but how to write a program that's not going to crash and not going to mess things up and not going to make you lose your engineering license, which you're getting imminently, right? Never happens. We're also going to be trying, kind of as much as time allows, to talk a little bit about what people are currently doing in computer science that's at least a little bit related to what we're going to be doing in this class. And again, I want to emphasize, I do not assume previous knowledge of programming. I know that most people have some previous knowledge of programming, and that just means that, hopefully we're going to have fewer and fewer bored people as the semester progresses, but we'll start from the basics. I'll try to keep you entertained as much as possible, but not everything is possible. Here's the marking scheme. So we're going to have labs. Those are going to be approximately weekly. Those are going to be worth 10%. There's going to be 3 projects that you submit. There are going to be quizzes, which I'm going to be talking about imminently. There's going to be 2 online exercises worth 2%. And then there are going to be the midterm and the exam at a time to be scheduled. So I want to walk you through some of the components of the course so that there is no kind of worry about like what's going on. So the labs, you have the lab in your schedule. You're not required to prepare for it. You can, of course, if you want to, but you're not required. The lab assignment is going to be posted on the course webpage. You must find a partner. You can talk to your neighbors. If you have friends, talk to your friends about whether you want to be partners. If you don't have a partner, just go up to a TA during the lab. We'll find you one. What if there is an odd number of people who show up to a lab period? Yes, that happens all the time. The TAs will figure it out, and one person might have to work by themselves. That's just how math works. So we'll give you full credit for the lab for making a good effort toward completing the lab. So what that means is that it's supposed to be a zero pressure environment. The assumption is that everyone who comes in makes a good effort. So like the only situation where we are, and that happens like once a semester to one person. Theoretically, it could happen to, but it basically never happens that someone is like, they're technically in the lab, but they're like clearly like, not even like watching TikTok. They're just like sitting there and not doing anything. So in that case, we'll talk to you. Even then, if you show up, you do something, we'll give you full credit. Okay. So there's going to be lab TAs there. I'll show you some photos of the lab TAs in a second. They're there to help you along. So, flag down a TA, ask them questions anytime. And then at the end of the lab, the TAs will walk around and check your work, give you feedback, and record the fact that, assuming you did, that you made good effort towards completing the lab and therefore deserve full credit. There's also going to be surprise quizzes. So that does not start until week 3 when we're settled in. There's going to be about 12 of them. In fact, the syllabus says 12, so 12. Those are going to be surprise quizzes. I'm not going to pre-announce them. And the way they're going to work is they're going to be online. So please bring a device to class. And then obviously I cannot police people Googling or talking to other people or anything like that. I'm not going to try. That means that the quizzes in practice are also going to be, you show up, you do the quiz, you get the vast majority of the marks. So like, like 0.01% is going to be assigned for getting the questions correct, just so that you don't feel like studying is completely pointless. The point is to keep you on track, give you some questions that are, again, kind of very low pressure, but let you know that if you're behind, you need to catch up. Okay, so doesn't start until week 3. We're going to have a rehearsal first before we do the first official quiz. I promise you it's going to be fine. I will say, so like it seems like a pointless waste of time. And I know, like what I will say is that last year, people who haven't done the 8 quizzes, meaning that they missed more than 4, got 7 points less on the exam than the people who did. Now, I'm not going to claim that because they didn't do the quizzes, they didn't get the 7 points. That seems questionable. It's more likely that it's a combination of factors of like, you don't go to lecture and you don't learn the material. But it's also the case, of course, that, if you're generally busy and kind of struggling, then you both are going to skip class and you're not going to do well on the exam. So there's all sorts of causation paths there. With that said, I think the 7-point difference is large and justifies the annoyance of having pop quizzes. Online exercises to be posted week 2, week 5. So just there to make sure that you're on track. So worth not very much, just to make sure that you've done some work before you submit project 1 and project 2, which are going to be the more substantial pieces of work that you do. So if you go back to the course structure, what is it that we're trying to do here? So the labs, the quizzes, the online exercises are just there to keep you on track. The projects are there to make sure that you do the work that's needed in order to kind of progress and really gain the skills that you could demonstrate on the midterm and the exam. Again, even the projects, even though those are seriously graded, are not there in order to assess you. They are there in order to give you the experience that you need in order to gain the skills that we then measure on the midterm and the exam. Now, the midterm and the exam are serious business. You go to a big room, you sit down, you write for 2 hours, and then we grade you on how many problems you solved. Yes. Yes. So the answer. So the question was: is it coding or is it handwritten? And the answer is it's both. It's handwritten, but you handwrite code. So you can go to if you go to the front page, you'll see the previous midterms and exams. And it might, I agree, it might look like it's kind of artificial, right? That's not what you mostly do. Certainly when you code, you don't first write on the blackboard. But not always, I would say. Like it's actually kind of an extremely practical skill to be able to write code on a whiteboard, because that's how interviews go. Like if you do a POI interview, that's what happens is they have you write code on the whiteboard. It's also, and the people who haven't coded before probably wouldn't completely kind of have insight into this answer, but I think it's deeply true that if you actually understand what's going on, it's an outcome of that you can code on a computer, and it's also an outcome of that you can write on paper. So even if outside of getting a job, which nobody cares about, you don't need the skill of writing on paper, it's still kind of a reflection of the underlying skill that you have at programming. So that is how I would defend it. The other is it's just like the practicality of it is that's how we do things, because there's no other way that we could practically do it that's better. Yes.
How strict will you be with syntax when it comes to handwritten code?
Let's maybe defer this discussion until like late October when it's going to be more relevant. But the question was, how strictly do we mark syntax? And the answer is we're reasonable about it, right? So if it's a short question where we're trying to see whether you know the syntax, well, we're going to be strict about it. If it's a longer question where what we're trying to do is figure out like, can you do problem solving using Python? Then if you miss a semicolon or something, not that there are a lot in Python, then we don't care. Yes. That is the last slide of today's lecture, which we'll get to. One with hope. Okay. Yes, so I would ask, okay, I did answer because it was a reasonable question, but yes, like if you're thinking, this seems like a question that only someone who already knows how to code would ask, maybe hold it until the end of the lecture. That's okay. Okay, all right. So we were talking about the structure of the course. So yes, again, the midterm and the exam, that's where the assessment happens. That doesn't happen in a while. The other things, like you should take them seriously. If you don't do the projects, or like if you don't seriously think about them, if you don't keep track of the lectures, well, like you're not going to do well in the midterm and the exam, but they're not there to assess you. So don't stress about it in the sense of like, I got to do it like right now, or I'm going to lose marks. That's kind of certainly not a big deal for the labs, for example. But, try to keep up because the midterm and the exam are going to test the underlying skills. So, okay. Learning to program. So we're going to, if you haven't ever programmed, then this might not make complete sense, but hopefully it will make a little bit more sense in half an hour. So learning to program is kind of the analogy would be, like learning to swim or like learning to ride a bicycle or learning a musical instrument. So it's much more about learning a skill that you can only gain through practice than it is about understanding the theory, right? So imagine, Introduction to Biking 101, where there is a lecture about how to bike. That would not make a lot of sense, right? They do have actually lectures in driving school, as you probably all know, but like mostly it's about gaining the mechanical skill, right? And they do have music theory as well, still. So the lectures are to give you the theory that they can give you, and you do need some theory in the same way that driving school, although kind of boring, still kind of makes sense, right? Different people might have different takes. But mostly you learn by practice. So you mostly learn in the lab. You mostly learn by following along with the examples that a given lecture. You certainly learn by doing the projects. Okay. Okay. All right. Okay. So now we're really done with the chit chat and I want to do some coding. So we'll start by just using the online tool. We'll move through 3 different tools for coding because you'll see why it makes sense. For now, just please go to this website. Okay. They're not displaying ads for me for some reason right now. Sometimes they display like ads for an MIT online course, which is kind of weird. Yes. Oh. All right. There. Okay. Hi. Hello. Okay. Hello, anonymous capybara. Hello, anonymous chinchilla. Armadillo. Okay. All right. So click the link. And this is going to go along with the course notes as well. So we go to expressions and variables. So this is where I'm going to be writing the Python code. So what is code? I'm basically giving instructions to computer. So here's the simplest kind of instruction that I can give. I can tell it print a number. Print the number 180, like so. And in order to execute this, I'm going to press visualize execution. So this program is about to be executed. So here, this is the command that's given to Python. And what you see here is that the number 180 was output, right? So that's kind of the simplest kind of program you can have is I just told it to print 180 and it printed 180 over there. So I can write something slightly more complex. I can say print 180 plus 10. So the follow-up course to this one is 190. And what's going to happen is it's going to compute 180 plus 10, and then it's going to print whatever the result is. So again, visualize execution, press next. Same dream vacay, not for a while. And what you see is that 190 was output to the screen. So let's flip to the other examples. So I'm going to expressions and variables over here. So you can have something like 4 plus 5. You can have something like 15 minus 12. You can also have stuff that you wouldn't have in your pocket calculator. So here you can say 3 equals 4. So that's probably new to many. So this is an expression in the same way that 4 plus 5 is an expression. It's just that it's not an arithmetic expression. So equals means if the left-hand side is the same as the right-hand side, then it's true. If it's not, then it's false. So in the same way that the value of 15 minus 12 is 3, the value of 3 equals 4 is false because 3 is not equal to 4. 3 is not equal to 4. So in the same way, you can have a compound expression here, right? So you can have like, is 2 plus 6 equal to 12? The answer is no, it's not. So that's false. We could have something, so just kind of to make the point. So let's print something complicated. So is like 12 times 90 equal to, let's say 7 times, so yeah, a little bit. Is it anyone? Can you tell? Okay. Yeah, well, it is false. How can you tell right away that it's false? Yeah. Well, so that would be like, that would be called the fundamental theorem of arithmetic if you want to be fancy about it. So this one here has a factor of 7, and this one here clearly does not. So that must mean that they're not equal. An interesting point, by the way, is that, can you prove it? Like, is it obvious? Well, if it was obvious that if there is a factor of 7 there, but not here, and that means that they're not equal, then you wouldn't need to prove it, but it's not obvious, right? The proof is you need to calculate it. And in fact, like proving that because there is a 7 on the right-hand side, it must mean that they're not equal. It's kind of complicated. You do that in third-year algebra. So, okay, that is false. Okay, all right. So that's like that. So it's not just numbers and it's not just values like false and true. You can have what's called strings. So those are just letters enclosed inside quotes. And that's also a value in the same way that this is a value. So I can have something like print ha, let's say. So that will print ha. In Python, you can actually add things that are enclosed in quotes. That's kind of fun. So I can print ha plus ha. And what that does, the technical term is concatenation. It puts those two together. So if you run that, it would be ha ha. In fact, like what is ha plus ha? Well, that's ha times 2, right? And you can, funnily enough, do that in Python. So you can say ha times 2. In fact, you can do times 22. And that would be ha ha as well. So again, think of it as an extension of what you can do with a calculator. It's just that in Python, you can operate on things in quote as well. And the rules according to which it works is that if you do string times 2, it just repeats it twice. Yes.
The example that's below, that's like one.
Yes. That's a good point. So for now, there's going to be a small subtlety there. For now, as long as you're consistent about it, you can do either double quotes or single quotes, and it's going to be exactly the same. So one complication is if you want like a quote that's inside the quote that's complicated, we'll talk about it later. Okay. Yeah. Other questions? Yes.
Output comes with 2 double quotes. Why is that?
The output comes with yeah, so that's because this is the value rather than the thing that's being printed. So we'll do that in a second. Yes. Yeah. No, you don't have to use it for the rest of your code. It's just that if you want to say ha, it needs to be either kind of double quote ha double quote or tick ha tick. So it's just that like you're enclose it like like you just want to be consistent about it locally. Okay. Other questions? All right. Okay. Well, we have to do the ha times 20 now that we mentioned it. I think it was in the lecture notes as well. But it's, it's just ha 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 20 times. Okay. So that's like that. It's not a super useful thing, but it's a nice example that you can see right away where you're operating on things that are beyond just numbers, and it works just like a calculator. Okay. So far, we've just been computing kind of single expressions. So that's maybe a little bit useful, but that's basically like using a calculator. So what Python allows you to do is write programs. That means you have a series of instructions that are executed where part of what you can do is assign values to variables. So here's an example. You can say memory equals 42. And that means take 42 and put it in memory. And then you can ask, what's memory plus 5? So let's do that in Python Tutor. So I say memory equals 42. So take the right-hand side, put it in memory. So this is unlike math, where memory equals 42 would be like an assertion. Memory happens to be equal to 42. No, that's not it. It's take 42 and put it in memory. And that is what happens. So the way Python Tutor visualizes it is it says the value 42 is now in the cell memory. All right. And now I'm saying memory plus 5, which I neglected to print, so it's not going to say anything. But if I had said print memory plus 5, then first 42 has been put in the what's called the variable memory. And now what I'm doing is I'm printing memory plus 5, which is 47. Right? So that's kind of like the smallest program that you can have that does something, right? So you had one step where you put 42 in memory, and then you had another step where you computed something using a value that was previously stored. So that's kind of analogous to how, in high school math or physics, you need to keep, like, if you are solving a problem, you can't get the answer right away, right? You need to go step by step. And sometimes you say, well, like, I'll remember that this was the result. And then you go to the next step, and so on. Right. And that turns out to be very general. So essentially what the program is, if you have some kind of problem, be it, a physics problem from high school or something else, and you have a step-by-step recipe for how to take the inputs and then transform them into the answer you want, that is what a program is. In this case, this was like an extremely simple thing. Like, you just take the input 42 and you output whatever the input was plus 5. You don't really need a program for that. You can do it in your head. But you can imagine it's being more and more complicated. So that is what we're going to be doing for the rest of the year, basically. Yes.
So, what is that where you add 5 to memory? It could change the variable itself, right?
Correct. So that's a very good point. And again, like, we're kind of like showing examples of how things work, and we'll talk exactly about what things mean as we go. So you're completely right. So this is an instruction. So this is saying take 42 and put it in memory. This is just an expression. So in the same way that when I said print 180 plus 10, I did not change the value of 180. I computed 180 plus 10, saying print memory plus 5, computes memory plus 5 and prints it, but it does not change the value of memory, right? So the way to remember it is, like if you had said something like print 42 plus 5, 42 is still 42. Okay, so that's like that. So, okay. So just kind of more examples. So you can imagine that this is actually pretty realistic. So you can imagine that, like if the average for you guys is it's about the 98, which I believe that's about what it is actually from high school. There is like an ANSI adjustment, let's call it. That's like, let's be generous about it and say 15. Where, like, you have this program where, you have the exam, you have the ANSI adjustment, and then you say, well, like, if the exam was 98, we'll take 98 minus 15, we'll put it in exam, and then the value of exam is going to be 83. Okay. Questions so far about this program? Not about whether it's realistic. Yeah.
So value that exam is holding has now been updated.
The value is now 83, right? So the equal sign in Python means take the right-hand side and stick it in the left-hand side. So let's actually kind of do this example just so that everyone sees it. In the meantime, there's a question there. Yeah. So like in my notes, it outputs it because that's how I generated my notes. The way we output is we say print. And that is what I'm going to do. So I'm lying to you just a tiny little bit for simplicity. Well, I'll kind of get to it in the future as well. For now, we just print. So exam equals 98. So take 98, put it in exam. Take 15, put it in ANSI adjustment. exam minus sign adjustment. So this would be 98 minus 15. And the instruction here is take this and put it in exam, right? So that means that exam is going to be now what? Correct. You'll get more than 83 on the exam. You're quick. So exam will become 83 because this means take this and put it in exam. And exam is now indeed 83. And now here 83 is going to appear. So that's that. Does that make sense? Questions? Yeah. So, like, let's not get hung up on the names right now or the fact that the interest is 5.4%. Great deal. So for now, what we're doing is we're just saying, you know, like this is what displays the values of the variables. We're going to talk about what in about a week. I'll talk about global, local, and stuff like that. Okay. Other questions? Yeah.
You have to put space between like everything.
No, so Python does not care about spaces. So and we're going to talk about style a little bit later. So in general, I just like Python doesn't care about a lot of those things. A lot of those things are just there to make things look kind of nice and uniform, but you don't have to. There's flexibility there. And there's different styles that people adopt as well. We're just not going to talk about it right now. Yeah, other questions? Yes.
A question about hardware, like where is the variable stored?
Where is the variable stored in the hardware? The answer is somewhere nobody knows. Like if you know about the different levels of cache in the CPU, like who knows? So like all of those things are virtualized kind of many times over. And of course, this is in the browser as well. Okay. Okay, all right. That was an advanced question that I kind of glibly dismissed. Sorry. Okay. So all right. So let's talk a little bit about syntax, which people ask me about. So syntax is something that is a word that you hear a lot. So even though it's an advanced thing, I think it makes sense to talk about it now, just so that we define all the terms. So what's syntax? So syntax is the rules according to which phrases and sentences are composed. So that's a term that comes from linguistics. So kind of before people thought about programming, people just thought about in language, what are the rules according to which you can put words together. So many of you have had it, like especially if you had English as a second language, you probably had it. If you only had kind of, I suppose, like if you're from Ontario, you would have had it in French, right? But there are rules which to us are implicit if we know the language, but there are rules about how you're allowed and not allowed to compose words, right? So like the dog ate my homework would be considered syntactically correct because the words can be put together. So a famous example from Noam Chomsky, the famous linguist from the 50s, is colorless green ideas sleep furiously. So that's syntactically correct as well, because the words do behave according to the rules according to which you're allowed to compose phrases. Just happens to not make any sense, but it's still syntactically correct. Something like my ate dog homework da is just not syntactically correct, right? So like you look at this and you say, this could not possibly be English in a way that the colorless green ideas could be, right? Why is that? Well, because you're not allowed to combine nouns and verbs and articles in this way in English. In other languages, you might. So in the same way, in Python, there are syntax rules about what you're allowed and not allowed to do. So a equals 5 is syntactically correct because it means take 5 and put it into the variable a. That is allowed. Something like 5 equals a, which you might imagine means take a and put it into 5, that makes no sense. You cannot put something into 5. That's not a variable. That's the technical term is a literal, but for us for now, that's a number into which you cannot put something. So that's just syntactically incorrect, right? So the distinction that people usually make is about syntax versus semantics. So semantics would be the meaning of the piece of language, right? So, something like how it's green ideas, like that's meaningless. Ideas cannot be green, right? The homework ate my dog actually might be semantically correct. It's just like usually homework doesn't eat dogs, but so so in Python, it's kind of the same thing. So it's easy, like you'll learn Python syntax quite easily. There are not complicated rules there. There's not much to it, really. So the challenge really is to get the semantics right. So the challenge is to say something that actually makes sense and to write a program that does something. So Python will actually tell you when the syntax is wrong. So if I were to try to input 5 equals A, there's like a little X here, which says that the syntax is wrong. That's a syntax error, right? So unlike with English, like if you say something syntactically incorrect, that's not a big problem. It'll tell you right away that it's wrong. You'll just fix it. The challenge is you get something that's syntactically correct. That doesn't mean that it does what you intend for it to do. And the even bigger challenge is figuring out what it is that you want to say and what it is that you want to solve. In the same way that kind of when you're writing an essay in English, like most of the challenge is figuring out what's the right thing to say. It's not like, how do I say things in a way that sound kind of like English? And it's not even how do I say things that are, kind of sound like they might make sense, like the homework ate my dog. Does not apply to Praxis. You can do whatever you want there. So, yes.
So, how is there able to tell you when this, like, if the code makes sense?
Well, so like there's different levels of making sense, right? So there's like make sense in the sense of it'll do something. There's make sense in the sense of it'll do what I intend for it to do. And then there is it makes sense in the sense that it does what I intend for it to do. And also I intend to do the actual correct thing in order to solve the problem. And kind of as you go up that hierarchy, things become harder and harder. Okay, so it's like a little bit of a philosophical point, I suppose. Like it's not something I would ask you on the exam or anything. Okay. Other questions about this? All right. Okay. So we actually have a few minutes due to heavy collaborator use, some tools for this presentation. Okay, we're all collaborators now. That's great. Okay. So I'll do kind of a slightly more substantive example. So that is what's called, okay, we've done that. So that is what's called conditionals. So here is a program that actually does something. I'll show it to you and then we'll walk over the syntax. So this computes the absolute value of a number. So the way it works, and you can kind of read it, it kind of makes sense in English, but you need to know the rules, of course. So what this says is if n is greater or equal than 0, then we just print n. Else we print minus n. Right? So in English, it should kind of make sense. It says if it's a non-negative number, just print it. If it's a negative number, print minus the number. So for example, when n is minus 5, you're going to print minus minus 5, which is 5. Yes.
Oh, like a reset thing. Or
Yes. Yes, it is. So, and that's the syntax piece, right? So the syntax piece is, this is how you write it. So you say if, then you have a condition, like for example, n is greater or equal than 0. And then you have whatever you do if the condition is true. If the condition is not true, you do block 2. Block 1 and block 2 are supposed to be indented. So that means that there are spaces over here and spaces over here. So that is also mandatory. Yeah.
You don't need to, like, the variables in the integer.
No. Okay, no, so in Python you do not. So I said n equals -5, whatever type -5 is, that's what n is for now. Okay, so that's the program. So let's go through it. We have 2 minutes. So n equals -5. Still angry with me about the last thing. So n equals -5. So here we're saying if n is greater or equal than 0, print n, but that's not the case, right? -5 is not greater or equal than 0. So that means that we jump to line 5 and we print 5. And of course, if it were positive, so if this were 12, I typed in 21, then it is greater or equal than 0. So we now can print 21. All right, so, okay, your first program, it printed the absolute value. I will see you on Friday. Thanks very much. See ya.
Thank you very much.
Bye.